All right. Hopefully this will work. Question. Okay. All right. Can you see? And all right. Okay. Man, I don't know what's going on with this connection here, but things are going on with this connection. It's com crap. I guess I'll have to deal with it as it comes along. Let's go back to what we were doing here, though. I got things I got to do regardless. All right. So here we tried 48 over 100. Did anybody get 48% as a reduced fraction? So 48% as a reduced fraction is, you could probably start off here dividing by 2 at the very least. Get 24 over 50. You divide by 2 again. So your final answer here should be 12 over 25. All right. So that's what we should have here first. All right. Don't forget here, everybody, I do encourage participation so that way we can all go over it together, all right? Yeah, there we go. All right. How about 250%? What's 250% here as a fraction? Just note this is a mixed number. Two and a half. Very good. And that's correct. So we take the 2 part here out. We leave the 50% part in. That's going to be 50 over 100. And so 50 over 100, that's equal to 1/2. So that's 2.5. Nice job. That's correct. Very good. Okay. Now, let's go over the next part here, which is what happens if you run into, these are for whole percentages here. Okay, so do understand, these are for whole percentages here, where we have a nice 250 or 48. What happens in this case if you're given, say, a mixed number fraction, mixed number percentage, or, hey, Austin, how you doing, buddy? Or what if you're given a decimal here? What would you do here in this particular instance? Well, in this particular instance, let's go ahead and show off exactly what will happen here in this case. Okay, so what's the key here? In this case, you could write it as 15.5 over 100. That part is still kind of true. But this is pretty awkward to work with because you have a decimal, and reducing with a decimal here is very, very strange. Instead, what we're going to do here is we're going to go ahead and talk about the key behind this process here. The key here is to move the decimal place over. Hey, Vernie, how are you, my dude? Just had a bugaboo of a time just trying to get this stream up. It's been a, yuck. I swear my connection is terrible. All right, so move the decimal place over, and what we're going to do here specifically is we're going to move the decimal place over as many We'll place it to the right, I should say. To the right until we get a whole number. Okay. Just finished school today? Very nice. Very nice. Well, welcome back to class. Okay. Now, one of the second keys is you finish at 3. There you go. Don't forget to move the same number of places for the denominator as well. Okay? Right on. Okay, so what do I mean by that here in this particular case? So here we got 15.5, and we're going to move that over 1 decimal place over to the right. Therefore, this is going to now become 155. However, we're going to move the same number of decimal places here in the denominator. Since we moved 1 here on the top, we're going to move 1 decimal place to the right here on the bottom. And we just fill in the gaps here with the 0. So in fact, what we are given here is we have 155 over 1,000. Okay, as we talked about in algebra before, everything is a balance. So with everything being a balance, this is the way we kind of want to go ahead and approach it. So we have 155 over 1,000. All right. Now, what we want to do next here is reduce this fraction down. We're going to go ahead and divide by 5 here in this case because, well, they end in a 5 and a 0 here respectively. All right. So let's go ahead and see what we get here. Well, if we do 155 divided by 5, do that one out, and that's going to be 31. And 1,000 over 5, 1,000 divided by 5 is going to be 200. And that is going to be our final answer for this problem. Apologies, they're doing yard work out there. Looks like they're doing yard work at my place. All right. Can't make this stuff up some days. All right, so that's going to be our final answer is 31 over 200. Okay. Any questions about that so far? Just want to be sure that that example was shown there. Again, if you have no questions, just type no in the chat there. Okay. Yeah, of course. Of course. Let's do 37 and a half, okay? Alyssa? Let's do 37 and a half. All right, so we're going to start off with just writing as 37.5 over 100. Okay? Now, what do we do next here, Alyssa? What do you think I should do here for this top number? I want to make this a whole number here, right? So how many places to the right am I going to move to make this top number, this numerator here, be a whole number? So how many places to the right? All right, good. We're going to move this 1 decimal place to the right to make this a whole number here. Okay, good. That's going to be 375. However, remember, everything in algebra is always a balance. So since everything in algebra is always a balance, we're going to move 1 decimal place over here to the right as well. Tack on a 0 here, so this becomes 1,000. Okay? Does that part make sense? I just want to be sure if that part makes sense there. Okay, cool. Okay, now we have 375 over 1,000, but we have to reduce it down to its lowest terms. So what can we divide by on the numerator? Oh, excuse me. What can we divide by on the numerator and denominator in order to get it down to its lowest possible terms there? What number does 375 and 1,000 have in common that we can divide by? Divide by 5, okay? So let's do that. Sounds like a plan. All right. So first, let's do 375 divided by 5 here. All right. Now, if you want to quickly just do these, then you can use a calculator if you like. That's perfectly fine. All right. So what's 375 divided by 5? What do we get there? All right, we get 75. Now, if you do 1,000 divided by 5, that's going to be 200. All right, perfect. Now, we have 75 over 200 here, okay? So can we reduce this down further? Yes or no? Yes, what can we divide by now? So if we can reduce that down, which I agree, J Dragon, what can we divide by now in order to reduce this down? Okay. 5? Okay, Hannah, totally agree. I said 5 again. Seems absolutely fair to me. Again, it's true because both of them end in a 5 and a 0. Absolutely right. Let's see what we get. Now, if we did 75 divided by 5, we're going to get a 15. And if we do 200 divided by 5, you'll end up with 40. Can we reduce this down? 15 over 40, yes or no? Is this reducible or do we stop? Okay. So Hannah says, yeah, we can divide by 5 here once again. All right. So let's divide by 5 here once again. And then finally, we're going to get our answer here of 3 over 8. We had to reduce a few times here, but we got down to our final result, which was, again, 15 over 40 could reduce again. We divided by 5 once again, and we got 3 over 8 as our final result. And that's our final answer for that. Okay. To that. All right. Let's go ahead and do the other example here. Excuse me. The other example here is to take something like this one here, 66 and 2/3%, for example. All we want to do here is just convert this into a mixed number, from a mixed number here, mixed percentage, into a proper guy here. So basically, what we want to do here is, if we are going to go ahead and convert this into a proper fraction here, what we want to do here first and foremost, and let's talk about the key here. Key here is to change the percentage from a mixed number to an improper fraction, then divide by 100 and reduce if necessary. All right. Let me go ahead and show off here at 66 2/3%. I'll show this off here and show you, actually maybe not 66 2/3%. Now let's try it with easier numbers. Let's be, I want to be easy with this so that way you guys can see where I'm going to go with this problem here. Let me try it with E here. That way it's smaller numbers and a little bit easier to digest. Now if I were to convert 10 1/3 here, 10 1/3 as an improper fraction, remember I would take 10 times 3 plus 1 over 3. So that's exactly what I'm going to do here. Just like we did before when we talked about fractions, I'm not going to do anything different here. So I have 10 times 3, which is 30, plus 1, which is 31. So here I'm going to have 31 over 3 as my improper fraction. Now I'm going to ask you to do is, you get to this step here of 31 over 3. Okay, that's perfectly fine. Now what you want to do next here is to go ahead and divide by 100. Okay, so here we want to divide by 100. So remember how it works here. When we divide by 100 here, we take our improper fraction of 31 over 3. And another way to write this is, if we divide by a number here, that's the same thing as multiplying as 1 over 100. Okay? And then we can see if we need to reduce down here, if it's possible. Again, it may not always be possible, so do understand. Whatever we get here may not be able to reduce. In this case, unfortunately for us, 31 and 100 don't have anything in common. So in this case, we'll multiply straight across. And so here we're going to get 31 over 300 would be our answer to this problem. And so this is essentially how we can take a mixed number percentage and change it over to a reduced fraction. Okay, and you're going to repeat the process here with the times 1 over 100 every single time in that process. Okay, so I just want to point out that is the big difference here between, say, doing a decimal where it's like, okay, you're just moving the number of decimal places. And for a mixed number percentage, you're first changing it into an improper fraction, dividing by 100, which is the same as multiplying by 1 over 100, and then reducing it down appropriately. Just a lot easier that way because it follows the same method that we talked about before when we talked about fractions with mixed numbers. Change it to an improper fraction and then do the calculation with it. Okay? Are there any questions about that? No? Okay. All right. Let's move on here. All right. Now we're going to go in reverse. We're going to write fractions as percentages. All right. This is actually not as hard as you may think. All right. For this part here, I am going to kind of encourage you to kind of do you can use yeah, it's just kind of like one of those things is like you need to, no, actually, you know what? I'm just going to type it out. What am I doing? All right. Let's talk about the key to these problems here because it only revolves around one thing. Do the division first. Okay, so do the division first and find the decimal equivalent. Okay, you're going to do the division first and find the decimal equivalent. Then move 2 decimal places to the right, all right, and find the percentage equivalent. All right. So here's a simple example. Here's this very first one you see here for 3/5. Now, if you were to actually do 3/5, you did 3 divided by 5, because that's what 3/5 represents. All right, you just do 3/5 here, and that's 3 divided by 5. All right, just another way of just kind of expressing that here. Now, if you did that out, 3 divided by 5 would be equal to, as a decimal, would be equal to 0.6. Now, since this is equal to 0.6 here, appropriately, all we need to do is take 0.6 and move that decimal place over to the right 2 places. We go 1 and 2. So what we get here is we get 60% as a result. And that's all you have to do. In all honesty, that's it. So find the decimal equivalent, move right 2 places, then you'll have your percentage equivalent. If you move right 2 places, that's the same thing as multiplying by 100. There's no difference. So let's try 7/8 here together. All right. Yeah, so this part here, again, if you want to use the calculator for this, that's perfectly fine. Now, let's use 7/8. What is 7/8 as a decimal? What's 7/8 as a decimal here? So basically on your calculator there, do 7 divided by 8 on your calculator. I don't want you to round. Don't round though. Actually, actually, that's a good point here. Let me note that here. Notes. Yeah, do not round the decimal. Okay. Yeah, 0.875 is correct. Okay. So just so J Dragon, don't round the decimal here. All right. Just keep it as is. That way, it's going to be like 10 times easier if you do. Okay. So you're not wrong. Like, I know how you got 0.9 because you rounded there, but I don't want you to round. So I'm glad you brought that up because you don't want to fall underneath that trap. So here we get 0.875. That's correct. Now, what's 0.875 as a percentage? That's close, Hannah. 87.5%. So basically, think of it this way. We're going to move 2 decimal places to the right once you have your decimal. So you're going to go 1, 2. Move 2 decimal places to the right. And so 87.5% is the correct answer. So we're not moving all the way to the right there, Hannah. Just 2 decimal places to the right here. Okay, and only 2. That's okay. That's why we cover these problems, so we can get that down. Okay, let's try that last one here. I do want to try this last one here because this one here is a little bit different, just in one respect, but not by much. All right, so let's look at 5/6 here. Let's do this one together here. I'll put this off here to the side. So remember that's 5 divided by 6. So what decimal do we get here for 5/6? So 5/6 here. What's our decimal equivalent here? It's going to be a pretty long decimal, mind you. Yeah. So it'd be 0.833 repeating, right? Absolutely true, right? It's going to be, like I said, a pretty long decimal here. So what I'm going to write down here is 0.833, and it kind of goes on forever, right? Those threes, they go on forever. Essentially, the threes repeat, forever, never, never. So let's take a look at the decimal, though, at 0.83 repeating. Whatever that, again, those threes repeat forever. Now, we're going to do the same technique here. Okay, so let's do the same technique here. Let's move over 2 decimal places to the right. So 1, 2. And so what we get here is we get 83.3 repeating, right? Those threes repeat forever. So basically what I'm saying is this. There are 2 ways to kind of write this final answer. One is 83.3 repeating like I have up here on the screen, just like so. Well, it'd be helpful if you could see it on the screen. That would be one thing. Okay, so I move this over here 2 spots. I have 83.3% repeating just like so. Now, the other part here that we want to do is, well, probably need to, give me a second here. Shrink my face down here. So, there we go. Give you guys a little bit more space here. See the work rather than my face. All right. So you can either write it like this, or just be careful on some of the homework problems. They may ask you to round to, like, say, 2 decimal places. So they may ask you to write, say, 83.33%. All right, so just be careful here. One of these 2 could be correct. Just depends on how many decimal places they would like you to express, or they just want you to put 83.3% with the little bar on top to note that 3 is repeating forever. So whatever you see there on the homework problems there, please be sure to follow that blue text that you see there for the problems that you're probably already used to at this point, but just want you to be aware about that. Okay? Yes, Hannah, this is 6.2. Any questions, guys? We covered 6.1 last time. So if you watch the previous video here on Twitch, then you get access to the 6.1 stuff. We covered it last class. If you click on videos on my channel, if you click on my channel and you click on videos, you can see all the videos that we've done here for the past couple weeks. All right. Very good. Very good. Give you some time to practice those once things are ready. Okay. That's fair, but that's why I have the replays here on Twitch for up to 2 weeks, and well, I should be uploading them to YouTube eventually. So, but that's why I keep those there just in case, so you have like a way you can watch the replays. So just in case if things happen, so which I totally understand. Okay. So here we have a table of percent equivalents. These are things that you'll see most often. So you say 1/6 as a percent, for example, you can reference the table here of 1/6 as a percent. You can see here it rounds to 16.7%. 0.375 is a fraction. All right, you just look in the table here, 0.375 is equivalent to 3/8. All right, so as you can see here, you can reference this table at any time. You can reference this table at any time. Again, you're not always going to have this table, or you're not always going to have fractions that'll look this nice necessarily. These are the most common percentages that you're going to see a majority of the time, but not every single fraction is going to be represented, obviously. and not every single percentage is going to be represented. So again, this is a nice little handy reference that you can use here to check out the decimal equivalent or the fraction. But now you have to know exactly how to actually find those percentages outright without having to use this table. Remember, this table is not always going to be with you at all times. Okay, so when you go to the next class up, this isn't going to be available to you. So be sure you know how to do the process here from a fundamental point of view. Do the division, put it in as decimal, move it over two places, and there you go. Because most problems here, many problems here won't have these guys here. But again, at least to start with, at least you'll see most of the common ones there, and then you can kind of put two and two together. Okay, so there's that. I'm not going to spend a ton of time on that because again, that's something that you guys will reference over time. So uh, like 0.6 repeating is 2/3. Okay, 66 and 2/3. All right, so I'll have you guys kind of look at that and kind of cover that as that's necessary. All right. Okay. let's talk about the next section here, though. This is what I wanted to go over here. So definitely need to cover this part here. All right. So using the percent proportion and identifying components in a percentage problem. Okay, so we did talk about in chapter 5 here, we did talk about cross multiplication. We talked about how to set up proportions. All right. And so if we want to talk about a percentage proportion, all right, then we can also do that based on what we've just talked about here in this previous section. All right. So let's take a good look here and see, again, we want to decide whether the proportion is either true or false. And we're going to do that here doing the same technique that we learned in the last chapter, which was cross multiplying. We call it cross product. Cross multiplication is the same thing. Let's go ahead and put that here. Okay, so we're going to use the same technique as we talked about from before. Okay. Let's take a good look here at this first one. It says, okay, is 1/2 equal to 25 over 50? So this is basically something we've talked about before. Okay. And as you see there, we just kind of cross multiply. So again, just draw your arrows just like this. All right. So here I have 25 times 2 equals 1 times 50. And all I have to do is determine, let's talk about the key here. The key here is to determine if the left-hand side equals the right-hand side. Okay? That's what we need to determine. If we have the left-hand side equals the right-hand side, then it's true. So if equal, well, all right. If equal, then true. If not equal, then false. Okay, so we have 25 times 2 here. That's going to be 50. So that's the left-hand side. Now, if the right-hand side is also 50, then these two fractions here are equivalent. And 1 times 50 is exactly 50. So that means that these are true. Okay? So just to basically just kind of break things down, all you have to do is cross multiply, find out if the left-hand side equals the right-hand side, and you call it a day. Test is due at 11:59 Friday night. So be sure to finish it by then. Okay. Let's take a look here and find out how we can solve for some of these problems here using the appropriate proportions. This talks about parts and wholes, and I want to talk about exactly how we can figure this out. It says For example, the fraction 3/5 is the same as the ratio, in this case, like 60 over 100. Now, probably not sure exactly how this works. This is a good picture here, mind you, but let's think of it from a practical point of view here. All right. So it says for an unknown value here in a percent proportion. Okay. Let's talk about each part here that we see. We're going to put these two proportions together. All right. Okay. So we have a part, which equals 12 in this case, a percent, which equals 25 in this case, and it says find the whole. Well, what does that mean? Let's talk about the setup to these problems, because the setup to these problems here are going to be all the same. And here's how we're going to do that. Setup is going to look like this. We're going to have the part on top, whatever number that is, the part goes on top, the whole goes on the bottom, equals the percent over 100. So this is the proportion that we're going to set up here. Part over whole equals percent over 100. Okay? And it says here, in this case, to find the whole. So essentially, since this says to find the whole number here, this is going to be our x value. Just like we talked about our x values here in our last chapter, when we talked about proportions here, it says, hey, I don't know what this quantity is. I have no idea. So since I have no idea what this quantity is, I'll just call that x, and then I'll figure out what I need to do from there. So in this instance, I have a part here, which is 12. I don't know what the whole is, which is x. I do know what the percentage is. The percent is 25. And then I have over 100. And all I need to do here specifically is I'm just going to go ahead and cross multiply. I'm going to use a little bit of algebra, and then we're going to solve for x. Let's cross multiply here first. So on this left-hand side, I have 25 times x equals 12 times 100. Get times here. Times 100. So I get 25x. 12 times 100 is 1200. Okay. Okay. Can anybody tell me, what should I do next? How do I solve for x again? How should I solve for x in this case? Remember, this is our little algebra part here. Divide by 25. That's correct, Hannah. Good. So I divide by 25 here. And just on the left-hand side, Hannah? Or do I do it to both sides? Both sides is correct. Very nice. Right? What we do on one side is what we got to do on the other side. That's correct. And again, you can use your calculator for this because they're going to get pretty large numbers for these. 1200 divided by 25. Anybody got an answer for me here? 48. Spot on. All right, good. And that's our final answer. That's our whole number part there. Nice. Not too bad. Okay. Now that you have a good idea about how to do this setup, all right? So this is the most important part here of this of these problems here, is just setting up the problem here and just knowing where to plop in the numbers. So I'm going to leave this set up here. I want you to try letter B. I want you to try letter B. All right? And then once you have an answer here for letter B, go ahead and put that in the chat. Let's take a minute and let's see if you guys can find that percentage. Then we'll go over the problem here together. %60. All right. Any other answers here before we give it a try? All right, let's go ahead and give it a go. See if 60% is our winner chicken dinner. So we have our part. Our part here is 30. Our whole here is 50. We don't know what percentage is, but we're going to call that X. And we're going to put that over 100. We cross multiply here. Let's see what we get. So here we get 50 times X on the left-hand side. And here we get 30 times 100 on the right-hand side. So here we get 50x equals 3,000. Divided by 50. And so if we do that out here appropriately, the correct answer is indeed 60. Very nice. Nice job. Nice job, Ola. All right. 60% is correct. All right. Good. So once you know this setup here and know where to plop in the numbers, all you got to do is do the same technique over and over again, and you should be able to find those answers there lickety-split. Any questions so far? No? All right. Good, good. All right, so hopefully those aren't too hard. You can see, like, hey, you know the setup, hey, then there's no guessing. You just plop it in wherever you want, where they need to go. All right. Know those parts, do the things. All right. All right, let's go ahead and do these other problems here. Okay, now, let's go ahead and take a look at some of these next examples here. I want to see what else we're gonna... Okay, that's not too hard. Okay, not as bad as I thought. All right, so this, it says find the percent in the following, okay? 32%, find the percent in the following? Okay, I guess. 32% of the 900 men were too large for the imported car, so 32% is the thing. All right, that's fine. Let's let's go ahead and talk about this problem, though, in a little bit more detail. I was like, find the percent. Yeah, we know what that is. All right. So let's talk about what we discussed here in the very first section of this chapter, in section 6.1. In section 6.1, we talked about the basics of percentages here. But the more important part was how to interpret the words in certain problems here. Remember how we broke down the problem here and says, well, what number of blank is, X percent, or X percent of some other number is equal to what? Well, that's what we want to interpret here in this problem as well. So here we have 32% of the 900 men were too large for the imported car. Now let's say I wanted to figure out what 32% of 900 meant. Well, in this case here, 32% of the 900 men. Now, there's two ways to interpret this problem here. We could set it up as what we talked about here in section 6.1, or we can set it up as the proportion that we've discussed here in this particular section. I'll show off both and show you that we get the same answer here for both cases. Okay, first let's try it the way we talked about in section 6.1. First, it says 32%. Okay, well, 32%. So the way we talked about it in section 6.1 is we can express 32% as a decimal. Okay, so how can we express 32% as a decimal? Let's at least answer that question here. 32% as a decimal is equivalent to what? What's 32% as a decimal? Okay, 0.32. All right, that's correct. Again, if you're not sure how we got 0.32 here, and that's okay. Here we get 32 over 100, right? And then you can figure out the decimal equivalent here, which is 0.32. Now, if we use the decimal equivalent here, 0.32, the next word we see here is the word of. Can anybody tell me here, what's the word of mean in mathematics? What does the word of mean in mathematics? We talked about it in the very first section there. So what does of mean in math? Hopefully you have that in your notes there. Multiply. That's right, J-Dragon. All right, so when we see the word of here, of means to multiply. So one of the kind of things in even though it's a mundane word, in mathematics at the very least, it does mean to multiply. So we take this 0.32 here and we multiply it by of 900 men. So we say 900. So we do 0.32 times 900. And again, you could do this on your calculator here. What do we get here for 0.32 times 900? What's that going to be? What do we get here as our final result? So 288 is correct. Good. So 288 is your final answer for this. That's 32% of 900. Now you're like, okay. That's a little bit confusing. Okay, you're like, all right, fine. That's a little bit confusing, and you know what? That's a fair thing to say. You're like, yeah, I'm not sure about that one. Okay, even though we did cover it in the first section, you're like, how can I make this a bit easier? Maybe I want to make it look like we did the previous example, just setting up the proportions appropriately. Well, there is definitely a way to do that here as well. Well, we have 32% here, and if you consider 900 here, 900 here is the whole here. So this is the whole here in this case. So what we have is we need the part. So I don't know what the part is. So the part here would be, say, the 288. We want to, again, basically what I'm just saying here is that we want to replicate the 288. We know what the final answer is. But if we get the same answer here, you're doing another technique, then it's just another option that you can certainly take to the bank. So here we have x, we have the part, which is x, over the whole, which is 900 people, equals the percent, which is 32, over 100. And then all we have to do here is to go ahead and do the process here. Again, the part here is x because I don't know how many people out of 900 32% is equal to. So here I'm going to go ahead and cross multiply. And so here I'm going to get, on the left hand side, I'm going to get 900 times 32 equals 100 times x. Now if I do 900 times 32, I get 28,800. Which equals 100x. Then divide by 100 on both sides. And so here we get, again, our same answer here of 288. So notice here we get the same answer here regardless which way you want to go. So again, you can convert it to a decimal like 0.32, or you can set up your proportion here just like we did already in this example, and we should be good to go. Okay. All right, questions about that? Oops, sorry. I accidentally moved up to, my bad. No questions? Okay. So next, okay, we're almost out of time here, but I want you to try one more example here for sure before we end this off. I want you to try letter C. Okay, let's try letter C here. What percent of 7,000 pounds is 3,500 pounds? Okay, now this question isn't hard here, but again, you want to talk about the setup here. Okay. So can anybody give me an answer for letter C? %50. Okay. I'm going to agree with you, Ola. It is definitely 50%. That part is true. Now, let me go ahead and show you how you could do that here. There's several ways you can certainly approach this problem and get 50%, but I'll show you with the proportion here. All right, so it says what percent here. Remember, we have the the part over the whole. Again, 3,500 you can identify as the part. You have the 7,000 pounds, which is the whole. And we're trying to find the percentage here. What percent? We have percent here, which is again x. Oops. Sorry, I did it the other way around. I want to start with the part over the whole part. Sorry. We have a 3,500 over 7,000 equals the percent, which is x over 100. You can cross multiply here. So again, we get 7,000x equals 3,500 times 100. So we get 7,000x equals 350,000. You go ahead and divide by 7,000 on both sides. Again, I apologies for rushing through this, but I'm just kind of out of time. So, and then what we get here is we get x here. We get x here is equal to 350,000 divided by that. That is going to be 50. So 50% is indeed the correct answer. Like I said, there's multiple ways to approach this. I'm going to show you the proportion way, but there's many, many ways to approach this particular problem. So I just want to point that out. All right. All right. Any questions about these type of problems? We may just start with this type of problem here for next time, just to kind of reiterate here. Let me yeah, well, we'll talk about those. So we have a few more problems here to discuss in this section here, but yeah, we'll get through these. Lot to do. A lot in this section, so mercy. No? All right. Good stuff. Okay, so for next time, we're going to go ahead and finish off here section 6.3. We'll maybe do one more example from there. We're going to do 6.4, which is again using the same proportions here as we talked about here in this to solve for applications. We'll discuss alternative ways to solve for these percentage problems. So we'll hopefully get through section 6.4 here also for next time. All right, so we'll discuss that here. We've actually already probably set this up here for next time in terms of saying getting the setup down at the very least. So the setup here is going to be the most important part here, but we're going to look at some more examples here certainly to discuss, either talking about our route here now or talking, like setting up our proportions, or again setting it up using our math language here, like we did in section 6.1. So we'll be looking at more examples here as time goes along for next class. So rest assured, even though I know I kind of rushed this last part here, next class we're going to have many more examples that will reflect pretty much the same thing. So that's what's on the docket here for next class. All right. So I want to thank you guys for coming on out now here for today to the stream. Again, apologies for the random mess ups here. I kind of wish that Comcast wasn't so bad, but it is what it is. All right. So that's where we're going to end off here for today. I'm going to keep the stream running here because we have people here from the next class possibly coming in. But for those of you in this 9:30 class, I hope you have a very wonderful morning / afternoon. All right, and I will see you all later. Yeah, you have yourself a great day, Alyssa. All right, take care of yourselves. Have a chance to relax a little bit and have fun. All right, when we will see you here on Thursday. Okay, make sure to get your test done there by Friday. Okay, if you haven't done so already, or at least practice with it, maybe in the interim. All right, and try some of the other problems that we've talked about here today as well for extra practice. All right, have a great one, everybody. And we will see you later. All right. Take care. Take care, first class. We'll be back on Thursday. As for the next class here, I will be back in about 5 minutes or so. All right. We'll see you. All right. Bye. All right, better? Hey, I think that's better. Hey, woke up a little late, so we joining in. Yeah, that's fine. Okay, cool. Do we have class next Thursday? No. No, we do not. This Thursday, yes. In 2 days, definitely. Next Thursday, no. Thanksgiving holiday. So, following still the same premise as before. So, the answer to your question there, Eric, is no. Yeah, of course. Always welcome to ask, my dude. Always, 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 always. Okay. Okay. Good morning, Patricia. Good morning. Good morning. Wait, seriously? Hmm. The strongest recorded bite force. Thing can snap your. Wait, it's like it's got mechanical jaws. Can just snap your arm in half. Oof. Oof. Any limb in half, really. Oof. Yeah. And that's why I don't mess with crocodiles. That's why I don't live in Florida. I totally believe it. I totally believe it. Those things are chonky boys. So, ha ha ha. That's like stronger than some of the machinery we actually have. That's crazy. That's absolutely not. Dang is right. Dang. All right, everybody. Let's go ahead and get going here. Uh, do need to get going with today's lesson. Okay. All right. So let's do this. Okay, let's get started today. Welcome back to Tuesday. All right. Hopefully, you have a nice weekend. So today we are going to be covering at least a section and a half here. We're going to be doing continuing on here in chapter 6 with first of all section 6.2, and then we'll get to about halfway. We'll get to most of section 6.3 here today. All right, with our material. Again, just as a friendly reminder, remember that the test for chapters 4 and 5 is due on Friday. So if I would suggest again, make sure you get do some of the homework and make sure to try on the practice test. Remember that the practice test, as always, is exactly like the real test. Um, again, question for question. So again, get a little bit of practice in. Then you could try the real test. Then you'd be good to go. So yeah, give it a try. I think that would be bueno. Muy bueno. Okay. All right. I got my deep voice like this. All right. In any case, all right. So today, let's talk about what we're gonna do today. So is this six? Oops. Let's put that up here. That's section 6.2, my dude. Section 6.2. All right. That's where we're going to start off here for today. Okay, with section 6.2, and then we'll do hopefully most of section 6.3, depending on how it goes for the rest of the stuff. All right. Okay. First of all, before we get started here, really quick, are there any questions regarding the test or the like here? Any questions for the test or the like that you guys have? Not. Oh, all right. That's fine. Just want to be sure that if you do have a question there, then feel free to ask. Okay. All right. All right. So let's go ahead and get going here with the first section then. There are no questions. All right. So last time we talked about the basics of percentages in section 6.1. Today we're going to take some of those concepts we talked about from the basics of percentages and being able to apply them say in this case fractional formats. So we're going to talk about how to write percentages as fractions, which we did talk about pretty much in the last section, but we're going to expand on that a little bit more. Go in reverse, talking about fractions and writing that as percentages, and then using using a table to find percentage equivalence. We'll talk about that briefly. I'm not going to go over the last part here very much. I'm going to just talk about it briefly and then pretty much move forward. All right. Well, let's talk about the main two, which is the first two parts here. Let's go ahead and talk about writing a percent as a fraction. Okay, so how do we write a percent as a fraction here? Well, it's pretty simple. If you have a percent, basically you can write it as p over 100. Okay, so if we had, say, 37%, for example, then we could write this as 37 over 100. Now, the one thing that we want to be doing here is it's not hard to figure out, of course, you get 37 over 100. Really, the key part here in this particular part here is that although we can express it as 37 or 100, because we're converting this into a fraction, remember with any fraction, we can reduce that down to its lowest terms. So that's what these examples are going to be talking about here. So this is going to be kind of like the first step here of having 37 over 100, but then we want to reduce that fraction down um, as such. Am I taking questions? Currently, Lucifer, I'm doing a lesson at the moment, but after my class here, you can certainly ask questions. So um, if you want to stick around until after that, or if it's totally up to you. But I will be teaching a lesson here, so I do apologize. But if you come back in about an hour, I'll be happy to take questions. So, all right, cool. All right. So, let's go ahead and take a look here on how we can take each percentage and put it as a fraction, and then we'll put it in lowest terms. Let's try 25%. So 25% can be written just like we have up above here. It's 25 over 100. Now all we have to do is take this fraction here of 25 over 100 and reduce it down to its very lowest terms here. So again, just like we talked about when we talked about fractions, all we need to do is find a number that is in common that we can divide by between 25 and 100. Again, that same number there, of course. So is there a number we can divide the numerator and denominator by in order to reduce this fraction now? 25. I would totally agree with that. 25 is correct, right? So we can divide by 25 on the numerator, divide by 25 in the denominator. So we get 25 and 25 here. So we get 1 and 4. Now you could also pick 5 here, like Sion says, and you just need to probably do the next part here. So again, you could do it in steps. You let's say you don't see 25, and that's fair. Like Daniel pointed out, it says 25. You're like, hey, all right, that's perfectly fine. So you could divide by 5 here first. 1/4 is our answer here, but I'll show the alternate method. So you may just need to take an extra step. So 25 divided by 5 is 5. And if you do 100 divided by 5, that's going to be 20. And then you just see, okay, you just answer the same question again. Can I divide 5 and 20? Can I reduce that down? The answer is yes. And I would divide both the numerator and denominator by 5 to get our same answer here of 1/4. Okay? So that's what we get here for a problem like this would be 1/4. Okay, in either case, they're the same exact answer. So if you need to take it 2 times to divide by 5, that's perfectly fine. If you divide by 25 here, that will be just fine as well. Okay, so alternate ways to get to the same result. One just takes 1 step, one takes 2 steps. Okay, so that part there, not so hard. Are there any questions so far about that? Nope. All right. Nope. All right. Hey, Samantha. I forgot to say hello. Oh my gosh. I have to say hello to Samantha and Robert and Carissa. I have to say hello to you guys. So, hello. All right. Um, nice. Um, all right. Now, the next one I want to look at here is I want to look at 150%. Okay. So at 150% here, okay, the important part here about 150% is remember, as it says here, we can write it as a fraction or a mixed number in lowest terms. Okay, so a mixed number here in lowest terms is what we're looking at here in this case. Now, we have above, so let's take a look here. There's going to be a couple of keys here, so let's look at that here. All right. So the key here is that if the percentage, so we actually, I'll say this way. We will get a mixed number if the percentage is above 100%. All right. So if the percentage is above 100%, then we're going to get a mixed number here. So I guess I'll put that as a note instead of a key. I have the key here, more importantly. Let's talk about the key here specifically, though. What's the key here to a problem like this? The key here to the problem like this is basically use the hundreds digit as the whole number and keep the rest as the fraction. Okay? You're probably saying, whoa, what does that mean? Okay, what do you mean by that? Well, all I'm going to do here in a problem like this is basically I'm going to take this one, and then this one here is going to be my whole number. So it's going to be 1. Then the other part here, which is the 50, which I'll circle, this is going to be my fractional part. This is going to be pretty much like it's the same thing as if I'm taking 100% plus 50%, right? So that's 150%, so 100% plus 50%. So essentially that's what I'm doing here. The 100% can be represented as 1, and the 50% can be represented as 50 over 100. And then we can reduce that fraction down appropriately, which in this case here is pretty simple. That's going to be 1.5. Okay, so 50 over 100, you can divide by 50 there, and you'll get a half for that. Okay, so that's how we're able to find those that answer there. Again, just separating out that hundreds digit and then just taking the rest and saying, okay, cool, fine. The rest of it, no problem, will be our actual reduction part. Okay, now that we have that as a premise here, let's go ahead and have you guys try a couple of problems, okay? I want you to try letter B, and I want you to try letter E. So try letter B and try letter E. Letter B and letter E. Right? So let's take a minute or two and do those two. And then you guys can tell me what you got for those. Okay? Let's give it a try. Just yeah, but I just regarded it. I saw it. I regarded it. B was correct. All right, Patricia got 12 over 25 for B, okay? All right. Okay, so we got that. All right. Look at that. I'll dig it. All right. Let's take a look at both of these. Let's see what we get. I dig these answers, though. Very good. So I'm going to start off at 48 over 100. All right. Now, there's lots of ways you can divide things out, but maybe you're like, okay, I want to divide by 2 here first. Okay, if you didn't see this right away, that's fine. That's why we divide by 2, a simple number. So we get 24 over 50, but as you can see here, they're both even numbers still. You can divide by 2 a little bit further. 24 divided by 2 is 12, and 50 divided by 2 is 25. And there we go. 12 over 25 for letter B is indeed the correct answer. 250%, we're going to take the 2, bring that outside. We'll keep the 50 in here, just like so. We have 50 over 100. And as was stated here before, 2.5 is your final result. Good. So a couple quick problems there, but certainly worth doing there in this case. All right. All right. Any questions about that? Nope. All right. So far, so bueno. Okay. All right. Now, let's talk about the next part here. Okay. Now, we're going to be writing a decimal or again a mixed number percentage here, and we're going to want to write that as a reduced fraction. So that's what we're going to be doing here, taking this percentage and but the key difference here is we're not dealing with whole numbers like we had in these examples, like 250 or 48. This time we have a decimal percentage. So the question is, how do we approach these type of problems here, like in this case? Okay, so let's talk about the keys here to this problem, and then we'll go ahead and proceed and do this. Now, the way we first want to approach this is the same way we approached the last set of problems. Because we could write 15.5%, for example, as 15.5 over 100. Okay, we can write it just like that. That's perfectly fine. The problem is that the numerator here is 15.5. Pretty awkward to actually go ahead and reduce down with 15.5. Not so easy to do because, well, decimals aren't very nice to begin with. So maybe we need to go ahead and take a look at a different way of approaching this. Okay, so what's the key behind problems like these? Okay, let's discuss about this here. Key. All right, what we're going to do is we want to make the numerator here. So make the numerator a whole number by moving decimal place over to the right um, until it is a whole number. Okay. Then, there's a second part here. Then, move the same number of decimal places to the right for the denominator. Okay. So this is going to be our key here for our for this example here. Now you're probably saying, well, whoa, 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 whoa. What do you mean by that? Okay, I'm here stuck with 15.5. I don't want to keep that as a decimal. That's not fun. So instead, I'm going to move this decimal point here. I'm going to move that to the right one decimal place. That way, on the numerator here, I'm going to get 155. Of course, though, as you see for the second line here, well, though I moved the numerator by one decimal place to the right, just like it says in algebra, everything is a balance. And since everything is a balance appropriately here, I want to go ahead and move this over by one decimal place over to the right here for the denominator as well. So in fact, we get 155 over 1,000. Okay, now we're not quite done just yet, but this is the big key to doing this problem here. Now we have two whole numbers, and then we reduce down after that fact. Okay, so now we can reduce it down from here and then see what we get for a problem like this. Okay, so take a look here at 155 over 1,000. What can we reduce that down by here? What can we divide the numerator and denominator by? 5, okay, that's fair. Again, we have a 5 and a 0 here, so yeah, 5 is fair. We can divide by 5 here, numerator and denominator, to reduce this fraction down. And so if we do this out here, we could do 155 divided by 5, which is 31, and 1,000 divided by 5, which is 200. And if you tried to do that out, that's as far as you can go. Unfortunately, 31 and 200 have nothing to do with each other. And yeah, that's it. So 31 over 200 would be your final answer. Okay. Any questions about that so far? We're going to do another example here, but any questions about that example? No. Okay. Now, let's try another decimal one here, and then we'll look at the mixed numbers one here. So, okay. So take a look here at 37.5. All right, so let's start off with that. Remember, just start off with 37.5 here, over 100. So we're just going to start with that. Okay? Now, if I were to make this with whole numbers here, what would 37.5 over 100 look like if I want to change those over to whole numbers for both the numerator and denominator here? What would that look like here in this case? Wow, 375 over 1,000. That's correct, Sion. That's right. So if we have 375 over 1,000, then we're just basically going to go ahead and put this over, move this over by 1 decimal place. This is where we get 375 from. But consequences, we got to do the same thing here on the bottom. That over 1 decimal place. The right. Have that 1,000 there. Okay. Now again, that's just part of the problem here, but we need to reduce this down. So we need to let's reduce it down here. What should we divide by here in this case? What do you think is a good number to divide both the numerator and denominator by? Divides both 375 and 1,000. Just pick an easy number here. Doesn't have to be grandiose. 25. Okay, 25 would work. Yes. Again, you could try 5 as well. Both are okay. Just to probably need to take that extra step. So let's take a look here. 375 divided by 25. What's that going to be? $15. Okay. And 1,000 divided by 20. 1,000 divided by 25. What's that going to be? $40. Okay. Good. Now let's answer the question here. Is this reducible? Is 15 over 40? Can we reduce on that? Can we reduce 15 over 40? Yes, okay, good. And so by 5, that's right. So let's reduce by 5 here. All right, good, good. Yeah, I was going to say 2/8. I'm like, that's kind of odd. So yes, that's correct. 3 over 8 is the correct answer. All right, good. So that's our final answer for that problem there. So sometimes you just need to go a few steps here to kind of reduce your fraction down. So it may take you a couple steps. Again, you just have to keep answering the question, can I reduce this resulting fraction down? If you find a number in common between the numerator and denominator, then go ahead and divide that out till you get down to its lowest terms, and then there you go. Okay, any questions about that? All right. Let's talk about the next one here, which is talking about a mixed number percentage. Nah. Noted. Nah, bruh. Nah. Right. Okay, let's take a good look here at the next one. 10 and a third. I want to do this next example here because and let's just keep it with simple numbers. And when we just keep it with simple numbers, it'll become simple to do the other ones that are also mixed number percentages and reduce it down to its final form. Okay, now let's talk about the key here in this case. The key here for mixed number percentages here is pretty much the same thing that we've done here for mixed numbers throughout this entirety of this course. Okay, the key is to change the mixed number percentage into an improper fraction. So just like we've done many a times before, we're going to take that mixed number percentage. We want to change that into an improper fraction. All right, but we still have a little bit more to do. Then divide that improper fraction by 100 and reduce as necessary. Okay? So that's what we have here in this instance. Okay, now let's take a good look here at these guys, right? And let's see how this works out. So if we want to take this in this case, let's take 10 and a third. The reason why I'm using 10 and a third here appropriately is because 10 and a third percent is typically, it's not very hard to figure that out. So I just want to show you how to pretty much easily do. So okay, let's take 10 and a third. Now 10 and a third percent here, or 10 and a third by itself, as an improper fraction is pretty easy. So all we have to do is take 10. Remember, we take 10, multiply that by 3, and add 1, and put that over 3. Now, if we do that out, of course, we're going to get 10 times 3, which is 30. 30 plus 1, which is 31. And so over 3. So here we're going to get 31 over 3. Now, it says here, once we do that, we're going to divide that improper fraction by 100 and reduce as necessary. So what we have here is we're going to have 31 over 3, those in parentheses, and I'm just going to put that over 100. Again, I'm not doing anything different like I did here for like decimals or with whole number fractions. I'm just still going to put it over 100, just like we had from before. Now, another way to express this is you look at this and you says, that looks pretty ugly. You're like, yeah, mainly that is pretty ugly. But how do we make this a bit easier on the eyes? Well, I'm going to go ahead and put 31 over 3. And we're going to multiply it by 1 over 100. Another way to express dividing by 100 is to also express it as times 1 over 100. And then we can see if we can reduce down like we did when we multiply fractions. In this case, unfortunately for us, 31 and 100 do not have any numbers in common that we can go ahead and divide by, where we can reduce. We're just going to multiply straight across here in this instance. So we get 31 over 300 here as our final answer for this problem. That's all you have to do for that part there. Pretty straightforward for that. Ah. Any questions about that? Hopefully that's not too bad. Easy peasy lemon squeeze. No, 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 and no, and no, no. Okay. All right. Let's move on here. Okay. Next, we're going to talk about writing fractions as percentages. Okay. This is not as bad as it may seem. We're going to take fractions, we're going to write them as percents. So we're basically going in reverse here. So let's take 3 over 5. Let's talk about the keys about how to do that, and it should be okay. Now for this part here, admittingly, you can use your calculator for this. That should be just fine. But we'll talk about each one of these examples you'll see up here on the sheet. Okay, first and foremost here, let's talk about the key behind these problems. The key is to take these fractions here. Remember that 3 over 5, for example, is 3 divided by 5. So what I would like you to do is to divide and put the answer into decimal format. Then move then move the decimal point over actually I'll say move, let me try it this way. Then move 2 decimal places to the right to get your percentage. Okay? So one of the things we talked about here is you could say when we talk about moving 2 decimal places to the right, that's pretty much the same thing as multiplying by 100. But before we actually do that here, before we even need to do that, is we need to put the answer into decimal format and then go ahead and convert it over. So for example here, if we have 3 over 5. Now if you did 3 over 5, the same thing for 3 over 5 is doing 3 divided by 5. And you could actually, again, you could do that by hand or again use a calculator. Regardless, you're going to get 0.6 here as a result. Okay, so you get 0.6 here. Now with 0.6, all you're going to do is you're going to move 2 decimal places to the right. So we're going to take 0.6, and I'm just going to move it 1 and 2. Where this decimal place goes. And as you see here, this is equivalent to 60%. Okay. So that's equivalent to 60%, just like so. So let's look at letter B. All right, so that's the easy one here, but let's look at letter B here, 7 over 8. So what's 7 over 8 as a decimal? What's 7 over 8 as a decimal here? What's 7 divided by 8? Again, you can just put that in. You can put that in a calculator if you like. So you got 7 divided by 8, just straight up. What's that as a decimal? Decimal answer. Okay. All right. So here's the part. Okay. I'm glad. No, this. Yeah, that's okay. Good. Good. All right. All right. Lots of things here. All right. So we have 0.88. We have 88%. We have 0.875. All right. So this is going to be an important note here for you guys. That's why it's a good thing I asked because again, just keep you on your toes there. So note here, do not round the decimal. Okay, so we are not rounding the decimal here. Okay, so I'm actually going to take straight up. If you do this out here, take this straight up here as 0.875. Okay, so I'm not rounding the decimal here. I know it sounds tempting to do, but we only round at the end of the problem and never in the middle of the problem. Okay, so we never want to round here unless it's absolutely necessary. So we get 0.875 here. Then we move that over 2 decimal places, 1 and 2. And so here we get, correctly stated here, as 87.5. So I just want to point that out here. All right. Let's try this last one here as well. What about 5 over 6? Let's find out what that is as a decimal here. It's 5 over 6 as a decimal. What's that going to be? Gonna get a pretty long decimal here, but to be fair. Okay. So you get 0.833 repeating. All right. So here's what you're going to get. You get 0.8333. Again, that 3 repeats forever. Again, you just get a bunch of 3's after that, right? No big deal. Okay. So what's the percentage here in this case? Because that is definitely, I agree, Patricia. That's definitely the decimal equivalent. What would be the percentage equivalent here? Yeah, and I'm glad you put a little question mark there because sometimes it can be a little ambiguous, to be fair. To be fair, this is a more of an ambiguous side. No, you're right. You're right. I said not to round here. Now, you're at the end of the problem here. So it's okay to round at the end of the problem. The middle of the problem, no. But that's why I don't ask you to round the decimal, because it's not at the end of the problem, it's still in the middle of the problem. But once you convert it to a percentage, that's when it's at the end of the problem. Right. So one of the things you'll find important here in math, regardless of what subject you're doing or what topic you're doing here, is that it will always be encouraged that you never round in the middle of the process. It'll just be encouraged that you round at the end of the process. Okay. That way you always get the most accurate answer every single time. Right. And that's always going to be a thing that we'll be doing. We've been doing here in this class, next class, the next class after that, and so on and so forth. Okay. That's not going to change. All right. So the only time you care about rounding is at the end. That's about it. Now, having said that, however, this part here can be a little confusing at times, and I just want to point out why. The correct answer is indeed 83.33%. That part is true. Again, you got 83 here, move that over 2 spots, get 83.33%. You can put it like that there. That's fine. You could also put it like this, 83.3 with the bar up top again, because those 3's repeat forever. You could put it like this, 83.3% repeating forever. Or you can also put it as 83.33%, as was stated in the chat. that's perfectly fine. The reason why I want to point that out is you just need to be a little bit careful on how, as you guys have seen many a times before on the homework, they may ask you to round to 2 decimal places. Okay, so just read that little blue text there just to see how many decimal places they want you to round. If they want you to put it as the bar, over the 3, you can go ahead and do that. Or if they put it 83.33% just like that, then that's fine too. Just depends what again, my math lab would like at the end of the day. But I just want to go ahead and point that out there so you're not caught unaware. All right. So just letting you know about that. Okay. So that's how we do those type of problems there. Really not too bad. Okay. All right. I'm going to have you guys can try some of these on your own. It's not going to be too hard. Um, but this is, I'm not going to spend too much time on this. There's a table here at the end of this particular section here that talk about common percentages, their decimal equivalents, and their fractional equivalents here. Um, this is, again, we've talked about the techniques about how to go ahead and find out. Do you have, yes, you do. Is that not enough time? 10 hours. Because if 10 hours is not enough time, I don't know what to tell you. You'll have to figure out how to spend. You don't have to take the whole 10 hours, of course, but I just put like 600 minutes. I'm like, yay, here's some time. So good. I mean, if 10 hours is too short, I don't know what else to tell you. I think 10 hours is plenty of time. So here we have again. I'm not gonna, like I said, I'm not gonna stress on this too hard here. Again, 1/6 is a percent. You can just look at the chart here for 1/6. Here it is. 1/6 is equal to 16.7% or 16 and 2/3%. Again, these are common percentages and common decimals and whatnot. I obviously don't cover every single percentage or every single fraction. That's why we went through the process about how to find that here at the very beginning. Um, nope, I didn't type it by accident. I just typed it because that's how I felt. So there you go. All right. So you can reference this chart here. Again, the idea is that for this chart, you're supposed to kind of get used to the chart here. Okay. You get used to the chart here. Obviously, you're not going to have this chart as you keep moving up classes. So again, just getting used to how what the fractional equivalents are going to be, or the decimal equivalents, is good for some mental math at the very least. But again, you can just match this up here appropriately, and it's really not too hard to do. So 0.375 as a fraction is 3/8. Okay, there's that fractional equivalent. Fine. All right, so just a common table here. I'm going to leave it up to you to pretty much use this table here. This is one part I'm not going to stress at all too much because it's just pretty much reading off a table based on the problem that they give. So, no big deal. All right, so I'm going to move forward here. Okay. All right, let's talk about the next section here, which is talking about something that we talked about in the last chapter, which was talking about proportions. Now we're going to be using percentages that we've talked about here in conjunction with proportions, and then basically finding out that, unknown variable here in this case. Okay? We talked about, like, when we talked about proportions here, we talked about the unknown variable. We talked about x, and we used a little bit of algebra in which to solve for that x. And the way we did that here specifically was, of course, taking the cross multiplication. Again, you'll see cross products here, but cross products here means cross multiply. So okay, so we looked at cross multiplying last time when it came for in proportions, and all we have to do in some cases, is we have to decide whether a proportion is true or false. Okay, whether they're equal or not. So if you say, hey, is this true or false? We can determine that really quick. So for example here, we could say, oh, is 1/2 equal to 25 over 50? Well, again, we could just take 1/2 equals 25 over 50. Again, we cross multiply just like so. Again, just draw our arrows just like that. And then we say, all right, well, we have 2 times 25 equals 1 times 50. And the key here to these problems, if we want to find out equivalency, key here is to determine if the left-hand side equals the right-hand side. If the left-hand side is equal to the right-hand side, then we're solid gold and we're good. If not, oh well, it is what it is. So again, if it's equal, then true. If it's not equal, then false. So here we have 2 times 25. That's 50. And all we have to see is like, oh, is the right-hand side also equal to 50? If it's not, then too bad, so sad. If it is, great, then it's true. And 1 times 50, of course, is 50 itself. So this is true. So as you can see here, that same technique we talked about in chapter 5 of cross multiplication, yeah, that still definitely plays a role here in this section as well. A very significant role, I might add. Now, how do we use that even further? This kind of cross multiplication and that proportion that we had set up here from before. Let's go ahead and talk about the next part here, percent proportions and whatnot. And we're going to take a look here specifically at example A. Okay, and I want to talk about each part here carefully, so that way you understand where we're plopping in numbers here appropriately. Okay, so let's take a good look here at letter A. Letter A says it gives us part here is equal to 12, percent here is equal to 25, and it says find the whole. All right, so we're given a part here of 12, a percent here of 25. Want to find the whole part here. Okay, so what is this whole part that we're talking about here? Well, that's going to be the equivalent. 12 out of something is equal to 25% of whatever. Doesn't really matter. What matters is the setup here for problems like these. All right, so let's talk about the setup for these problems here, about how to find this, let's say in this case, the whole part here. As you can see up here really quick, again, it's just going to look something akin to this. But if we have a universal setup for all of these problems, well, then I think that's significantly easier than just kind of putting it, visually every time with these boxes. All right, so the setup looks like this. We have the part over the whole equals the percent over 100. So the entire setup for these problems here is like saying, okay, what's the part? Part is 12. What's the whole? Well, I don't know what the whole is because we're trying to find the whole here. We're trying to find the whole here, that's going to be x. So let's just plop in the numbers and let's solve for x here in this case the same way we did back in chapter 5. So I put in the part, which is 12, over x, because I don't know what that is, the whole part there. Percent here is 25. And the whole is 100. And we'll go ahead and cross multiply here. So here we'll have 25 times x equals 12 times times 100, sorry. Almost put 200 there, but that's not what I wanted. Pardon me. Should be times here. Okay. So we get 25x equals 12 times 100 is 1200. Okay. All right, so really quick here. What do we do next? How do we solve for x? This goes back to chapter 5 here. So this is our little bit of algebra here. How do we solve for x here in this case? Divide by just the 25. On just one side? Or both sides, Carissa? So I should just divide by 25 here? On both sides, that's right. I have to divide by 25 on both sides. Remember, everything in algebra is always a balance. Okay, balance, 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 balance. Right. So it has to be what we do on one side is what we got to do on the other side. Okay, always a balance. So we got 1200 divided by 25. What's that going to be? $48. Great. That is correct. All right. See, not as bad, not too bad, right? Very, very simple and straightforward. All right, not too bad at all. 48 is definitely correct. Very nice. All right. Any questions about that so far? I'm going to do a few more here, of course. All right. Let's do the next one here. All right. Let's do the next one here. So let's do let's do letter C here. So here we have the whole being 150, percent being equal to 18. We want to find the part. So let's do letter C. Again, you have the setup right here. Okay. So let's do letter C here. I'm going to zoom out here for just a second so you can kind of see that appropriately. There we go. Okay. So let's set up the problem and then tell me what you find for your missing value there. Let's take a minute and let's give it a try, okay? Okay, that would be the correct setup there. I agree with that, Patricia. Now, can you tell me what x would be equal to? Well, the setup is definitely correct, Patricia. Now, just got to solve for that x. Okay, you got x is equal to 27. All right, let's see. Anybody else got any other answers there? All right, got the same part there. Okay, okay. I see good answers there. All right, let's go ahead and be sure. All right, so let's go over this here one more time. We got the whole here at 150, percent is 18. So again, the part here, find the part as it says here. So that's going to be our x right there. We're going to have x here as is appropriately stated, x over the whole here being 150 equals 18 over 100. Again, that being the percentage here given to us. I'm going to go ahead and cross multiply here. So cross multiplying, we get 150 times 18 equals 100x. The 150 times 18 is 2700 equals 100x. Go ahead and divide by 100 here. And so here we get x is equal to 27. And that is the correct answer for that. All right, good. 27, absolutely 100% correct. Very nice. All right, so far so bueno. All right, good stuff. Any questions about that? No? All right, very good. Let's look at, go ahead and take a look at the next part here. Okay. All right. Now the next problem here, the next, we're going to do 2 more examples here. That's what I kind of want to end off here with, at least for this one. So we took a look at these type of problems here in the very first section of this chapter, in section 6.1. If you remember our kind of quote-unquote math language here with percentages, remember that it is a little bit different than that of just saying, like, for example, here we had the word of. Of has a different meaning in math language than it does just being a regular mundane word we use in an everyday basis. Okay, so we see that we have 32% of 900 men were too large for the imported car. Now, the important part here is, how do we solve for what 32% of 900 men would be? Well, there are 2 methods to go ahead and do this, okay? And again, the reason why I'm going to show 2 methods here is because both of these methods can be very viable for a lot of the application problems that we'll see in the next section. So it's still going to be one of those things that certainly we want to represent. All right, good. It was being bad for a second. I'm like, it's not how it's going to work near the end here. So we're going to convert a percent to decimal here. So here we have 0.32, okay? 32%, sorry. 32%, as I just going to mention here, is going to convert over to 0.32. Now, the more important part here is we have 0.32 of. What does of mean again in math language? You guys remember? What does of mean in math language here? What does of mean in math language? Talked about it in section 6.1. Do you guys remember what of means? Not quite. It is, I mean, no, not in this case. We'll talk about the part of a whole here, but that's the second method here. So, but I want to know what of means in terms of a regular percentage math language sort of thing. Again, if you take a look back at your notes there from section 6.1, you'll see what we referred to of as. Multiplication, that's correct. So one of the things that we did talk about here is of means to multiply. Okay? So again, our mundane word of here, in math language anyway, means to multiply. So what we have here is that we have 32% or 0.32 of, which would mean to multiply by 900, in this case for the 900 men. So this is how we set that up. We say 0.32 times 900. Can anybody give me an answer for this problem here? $288. Okay, so now we have expectations here. We know what those expectations are. Okay, those expectations are going to be, again, we know that this answer here should be 288. So this first method here, that's how we can directly find 288. Perfect. Now let's try method number 2. Now with method 2 here, we're going to find the same answer, so we know what to expect. Our answer here will still be 288, okay, underneath this second method, but we're going to find it a different way, okay. Method 2 here is to basically use proportions. So just like we've talked about here already in this section. So we're going to use proportions here. We're going to use the part and the whole, okay, and the percentage part. Okay, so we're given the percentage part here of 32. Now the 900, let's take a look at the 900 part here. The 900 is the total amount of people that they tested, for example. This 900 is going to be your whole part here, okay? So what we have here is, if we're going to use the proportions like we did in the last example, we don't know what the part is, that's going to be x. We do know what the whole is though, that's 900. And this is going to equal 32%, or 32 over 100. So the percentage over 100. And then we just go ahead and solve for x just as normal. So what we get here is we get 32 times 900 equals 100x. And if you do 32 times 900, that's 28,800, which equals 100x. Divide by 100. And so here we end up with x being 288. So you can see here, this second method that we did nets us the same exact result as we got here in the first method. So you can use either converting it into decimal and then using the proper language to solve for your missing part, or you can use the second method there and using proportions to solve for your missing variable there as well. Both methods are just fine, again, just go with the one that you're most comfortable with. That's going to be that will end up to be your go-to every time, okay? But this will be important here for especially for the things that we'll be talking about here that's the things we'll be talking about here in the next section, especially is setting up these problems here in a similar manner, okay? Um, any questions about this second method here? Really quick. No? Okay. I think you forgot a zero there, Carissa. You should get 288 because it's 28,800 divided by 100. So 2 zeros will get canceled out. Almost there, Jacob. Got one more thing to do here. We'll talk about that. All right. What I'd like you to do next here is I'd like you to go ahead and try letter C here. It's a quick problem here. So let's take this is a pretty simple problem here, but it says what percent of 7,000 pounds is 3,500 pounds? So it's a quick type of problem here, but go ahead and give that a try here for a minute or so. That's okay. It happens, Carissa. We're all good. All right, so what's the answer to C here? What percent of 7,000 pounds is 3,500 pounds? Go ahead and give that a go. All right, 50%. Very good, that's correct. So there's a couple ways to solve this. Now, if you solve this using the proportion method here, we're just trying to find the percentage here. It says what percent. So we're given the part here, which is going to be 3,500, and the whole here, which is 7,000. So you have here specifically, you have, yes, I'm kind of running out of space here, but darn it, I want to do that. So here we're given x. No, I was right the first time. Never mind. God, that looks so awful. All right, let's try this again. All right, we have 3,500 over 7,000 equals x over 100. Cross multiply, we get 7,000x equals 3,500 times 100. So we get 7,000x equals 350,000. Divide by 7,000 on both sides. Sorry, I'm doing this fast here. Apologies about that. So here we get x is equal to 50. It's a little messy here, but there you go. So 50% is the correct answer for that. All right, so think about these proportions here, or again, a way we're going to be interpreting these problems here when it comes to doing certain problems. Again, both methods are very viable. It just depends which method that you're comfortable with, whether it be the decimal version or whether it be the proportion version. Either way, you'll end up with that correct answer at the end of the day. Okay, any questions? Sorry, I kept you a little bit over time here, but I wanted to get that last one in. All right. Nope. Okay. So as for homework there, as Jacob had asked, homework here is going to be section 6.2 and 6.3. Okay. That's what we did here today. So we may just end up doing one example here from 6.3 for next time, and then we'll get right into section 6.4, which is doing some more application problems, okay? And being able to interpret them, all right? So we'll be continuing moving forward here for next time. All right. I want to thank everybody for coming out here today. All right. I really appreciate it. All right. I hope everybody has a very wonderful afternoon. All right. Be sure to take care of yourselves. All right. And yeah, we will see you on Thursday. All right. Have yourself a great day, everybody. All right. And take care of yourself. I need to let's see here. I see Anna there. Yeah, you too. You have a great one. Anna, you there? I just want to ask. Anna, are you there? I just want to ask you a quick question. Six point three was 6.3 was talking about the part and whole part. So we actually did section 6.3 right here. 6.2 ended after we talked about percentages and fractions. And then 6.3 was doing the part and whole stuff. Daniel. So, yeah. Kind of seamless. Yes, seamless POG transition. Anna, are you around? I hope you are. If you're not, that's okay. But I just wanted to ask Anna a quick question. So, but if she's not around, then so be it. Send you a whisper instead. All right. All right. Go. All right. So that'll take care of it for today. All right. Thank you everybody for coming out to the stream. All right, and we will come back on Thursday. All right. Have yourself a great afternoon, and we will see you later. Take care. All right, everybody. All right.